Physics is the branch of science that deals with the structure of matter and how the fundamental constituents of the universe interact. While you keep the definition hanging, let's briefly discuss what the history of physics look like, who have contributed to what we have as physics today. Now, first of all, have you ever wondered about working of things you see in your environment? Majority of these things elude your imagination. For instance, the instinct a man have is to figure out what is happening. If something that is around you just changes suddenly, you want to know why it changes, what is responsible for it. Look at day and night. The alternation of day and night is enough a miracle for a man to begin to find out what is happening. And of course, day and night is also accompanied with moon and sun appearance. All of these are sources of agitation to find out what is happening. Now, the earliest occupant of this universe, they were met with all this curiosity. Hence, question of how things work, why do they work, when did they work, what works, started to arise. And of course, this led to dedication to study of our universe. For instance, you begin to ask, why is it day? Why is it different from night? Then again, the crops grows following certain pattern, and people start migrating from one place to the other. Now, you also look at the issue of weather instability. While you begin to study how weather work, you begin to see that some differences started arising that cannot be easily explained. Then rainfall is also an issue. You begin to find out where is this water coming from, which sometimes and always become very scary, is an issue. And of course, what happened is that the earlier scientists, started the study of what is really happening, and then it was only physics that come into play, because it remains the only subject for the study of nature. But the field that preceded physics were astronomy, optics, and mechanics. Of course, they later collapsed into physics as a course. And these are all methodologically united and through the use of geometry during that time. Greek and Romans, they were the earliest people that tried to logically describe various natural phenomena. So physics is the earliest science, and all other science technically, and of course content from physics. The journey to development of ideas started with some great individuals you can see within this picture. And what I'm going to do is just to discuss about 3 or 4 of them and their contribution to physics. Let's start with Sir Isaac Newton. Newton was born in 1643. He's a great mathematician and physicist. His great work includes law of gravity and Newton's law of motion. And even if you're outside the profession of physics, you must have been hearing law, gravity, and of course laws of motion. The second person is Albert Einstein. He was born in Germany in 1897. He is popularly referred to as father of modern physics. He developed the special and general theories of relativity and the greatest mass energy equivalence. E is equals to mc square. This one has a lot of story behind it, and the development of atomic bomb and all that. These are supposed to be the source. Galileo is an Italian who was born February 15, 1564, and he died in 1642. Although he also preceded most of the people I'm talking about, but he's a natural philosopher, astronomer, and mathematician, and he made quite a lot of big fundamental contributions to the sciences of motion, astronomy, and strength of materials. Next is Max Planck. Max Planck was born in 1850. Next is Max Planck. Max Planck was born in 1858 in Germany and lived until 1947. He's a theoretical physicist who originated quantum theory, and that one won him the Nobel Prize for Physics in 1918. He made many contributions to theoretical physics as well. Then let me talk about Stephen Hawking. This is somebody I particularly like because despite his situation and some of the things that befall him in life, he was able to contribute very well to physics. He was actually born in the year 1942 in Oxford, and he died in 2018. His works include Theory of Exploding Black Holes, which was very famous and extremely highly regarded. Physics and rocket science. Is physics a rocket science? Maybe yes, maybe no. Well, rocket science is actually a colloquial term for aerospace engineering. And rocket science is also humorously and colloquially referred to as something that is very difficult or to understand. However, it's the primary branch of aerospace engineering and is the science of building and designing rockets. You know, building and operating rockets, designing it, follow Newton's three laws of motion from physics. So, rocket science can be said to be a sub-branch of physics, and contrary to the wide belief that physics is tough and of course it's rocket science, you know. But the truth is, whether it is physics or rocket science, these are very interesting, and this is the only course that is studying what the earth is, and of course trying to also find out how this earth came into being through different kind of research that is ongoing. Now I will show you all the principles that is used in rocket science, and of course also try to prove to you that physics is easy and you don't have to be scared because it is a family of rocket. Physics and mathematics. Mathematics is an essential tool for physics. You don't have to be a math genius and know every mathematics before you do physics. You just need to pay attention to details, and skill you need will gradually develop with constant practice. Consequently, you will learn a lot of maths on your way, and that will be so effortlessly. So, mathematics is not an intellectual roadblock to learning of physics. With some adequate knowledge of calculus, vectors, linear algebra, and the likes, you will learn all this, and of course, they are easy to be learned and they will be sufficient for your initial journey into the application of physics. The foundation of physics, as earlier explained, lies in the curiosity of life, how things work, how we move, what are the constituents of matter, and even the universe. This led to research in physics and discovery of many theories for development and manufacturing of basic life comfort devices that is our continuous existence as we have it today. A very good example, which I need to briefly talk about, is about ironing of our clothes. Iron draws electricity from the mains and heat a coil inside. This heat is then transferred to the bottom plate known as sole plate, which is pressed against the cloth you are, ironing. To remove, let us look at another important application, which is in sound. In physics, sound is a type of energy made by vibrations. When an object vibrates, it causes movement in surrounding air molecule. Sound systems work by taking an audio input signal, processing and amplifying it through a series of equipment in a specific order, and then outputting the signal through one or more loudspeakers. I know we all have loudspeakers in our house. The ability or what we are able to achieve today in sound is due to the work of physics. Ballpoint or biro. Before the ballpoint or biro that we use today, People used to cut quills into nibs with a slit into the tip to hold ink to a sheet of paper, and of course, then they also call some papyrus. This is with the problem of leaking ink, smudges, and pulling ink blots. However, the use and discovery of biro comes with the advantages of the ink that is usually quickly drying. It has longer longevity and lesser smudging. Ballpoint pen or biro uses gravitational force to sink the ink down into the reservoir, which is dispensed through the medium of contact with paper, and of course known as ball. So as this pen presses against the surface, the ink flows onto the ball, which moves and basically pulls the ink onto the surface. Just with a mere law of gravity, this wonderful invention was made for us in this world to enjoy. Next is batteries. We use batteries every day for our portable electrical devices. The current life of mobility we are living, is made possible thanks to the technology of storing electrical energy into the batteries, which was one of the earliest discovery of physics. Batteries are a compact source of energy. Energy storage is a major problem throughout the world. Battery solve this problem by reducing the storage capacity very little and eliminating the need to carry fuel all around. Seat belt. Let us look at another important application of physics, which is seat belt and its application. Seat belt is very important for safety of man. We use it in car, we use it in safety of man. First law of motion comes readily into play in this technology. The unwillingness of body at rest to move and unwillingness to stop, the inertia, and of course the momentum principle of physics. Unless that body is impressed by a force, what summarizes the technology behind the seatbelt as we see today. The major advantage of seatbelt is to cause limitation to injury in the event of an accident. You find it in cars, you will find it in the aeroplane and some other moving devices. Cell phone. Cell phone use antenna to transmit and receive radio waves that carry information. The earliest contribution of physics to the study of waves and sound propagation is the basis of development of communication devices, and of course the communication technology of electromagnetic ray radiation transmission and use of semiconductor, which are what we call a mobile phone today. In health, magnetic resonance image (MRI), it's an invention of physics, and it starts, of course, it uses a technology which has a large magnet and radio waves to look at organs and structure inside a patient's body. MRI uses basic principles from optics and wave, as well as electromagnetic radiation, to scan and detect bad diseases that was elusive of science over time. Now let's look at friction. Friction is the resistance of force that slows down or prevents motion. It is necessary for many applications where you might want to hold items or things and prevent slipping or sliding. The sole of our shoes, they were made rough to prevent slipping while we are walking. Driving on a steep landscape may be impossible if not for the application of friction to the tire surface. Doppler effect, and sometimes called Doppler shift, describes the changes in frequency of sound or light wave produced by a moving source with respect to an observer. The police uses Doppler effect when checking for speeding vehicles. A radar gun sends out radar waves at a particular frequency. As the radar wave hits a vehicle, the wave reflects back towards the radar gun at a different frequency. So the frequency of the reflected wave depends on the direction of the speed and the speed of the vehicle. The faster the speed, the greater the frequency change. Aside, it's also used for a variety of other scientific disciplines, including planetary science, astronomers. The astronomers rely on it for Doppler effects. Now, briefly, let's just look at electricity. Electricity is one of the earliest useful discovery in our lifetime. It seems that nothing will work in this world without electricity, and of course, it's true. So, since electricity is a natural force that exists in our world, we did not invent it. However, we discovered it and understood it. So, credit is given to Benjamin Franklin, who discovered electricity. He was the one who came up with the idea. He was the one who came up with the idea that electricity had positive and negative elements, and that electricity flowed between these elements. We rely on electricity to prepare food and other domestic activity like playing television, so using branches of physics. There are two major branches of physics. They are classical physics and modern physics. Physics that are dated before 1900 are considered classical physics, whereas the physics dated after 1900 are considered modern physics. In this presentation, we shall look at some of the prominent branches of physics. The branches we'll look at actually are plasma physics, geophysics, mechanics, electricity, optics, electromagnetism, astrophysics, and so on. Now, let us look at mechanics. Mechanics is the study of interrelations between various concepts such as motion, force, matters, and so on. It works on the concept of force, matters, and so on. It works on the concept of movement and motion of objects with or without force concepts. Has really helped us, and it made us know about the law of motion, friction, gravitation, displacement. Mechanics is divided into two study areas. We have the quantum mechanics and classical mechanics. Thermodynamics. Thermodynamics deals with heat and other forms of energy. Steam engine brought this area into limelight in the 19th century and has remained relevant since then, with application in all other areas. Thermodynamics revolve around three laws that are considered as the foundation of this branch. We also have concepts like convection, radiation, and conduction, which is studied under this branch. Atomic physics. Atomic physics is a part of physics that manages the creation of the particles separate. It is concerned with the plan and conduct of electrons in the shell around the core and the process of change in this management. Hence, for most part, nuclear physics look at electrons, particles, and molecules. Primarily, atoms are considered in isolation in atomic physics. Nuclear physics. Nuclear physics. Nuclear physics is the field of physics that studies the constituents of matter, that is proton and neutron, and of course interaction between them. Application of nuclear physics are nuclear power generation. We are used to this. We know that this one is one of the cheapest way of generating electricity in the world. It also helps in the advancement of medicine, materials, energy, security. Geophysics. Geophysics is a specialized branch of earth science that studies the physical properties and physical process of the earth. Element of geophysics. Major elements that are studied under geophysics are shape of the earth, gravitational force of the earth, volcanic activity, composition of the earth, water cycle, and so on. There are problems that geophysics address for us, and this includes building of highway and bridges, mapping and exploration of mineral resources, mapping and exploration of water, geological mapping,